All right, let's get right into it. For the longest time, we've had this idea of sea level rise as this really slow, predictable creep. But what if I told you that was all wrong? Today, we're diving into a discovery from the deep ocean that is completely flipping the script on our coastlines. And it all kicks off with a forest that, honestly, shouldn't even exist.
So this really gets to the heart of it. On one side, you have the story we were comfortable with, the one we've told for a century, a nice, slow, totally predictable creep. But on the other side, the reality. The fact that the sea can just jump. We're talking rapid, sudden leaps. And the evidence? Well, it's been there this whole time, just waiting for us.
Okay, so let's set the scene. We've got to go back a bit and talk about this myth, really. It was a comfortable story, and for most of the 20th century, our whole worldview about the oceans was built on this one, simple, and honestly pretty calming idea.
And this quote right here, it just nails it. This was the thinking. Scientists even had a name for it, the gradualist paradigm. Sounds kind of fancy, but the idea was simple. Yeah, coasts change, but they do it so slowly. Over centuries, even millennia. We'd have all the time in the world to figure it out. And that idea wasn't just in textbooks, It shaped how we built our cities, how we made our laws, everything.
And this number, this was the linchpin. 1 to 2 millimeters a year. I mean, what even is that? It's like the thickness of a credit card, maybe a dime. It felt so small, so manageable. It basically let us all breathe a collective sigh of relief and assume tomorrow's coast would look just like today's. But, well, nature had other plans. Okay, so now we get to the part where the story takes a hard turn. This is the moment where that comfortable old myth runs headfirst into a brick wall. And it all starts with a discovery, something so bizarre it just shouldn't be possible. I mean, really, think about this. What if someone told you they found an entire forest, perfectly preserved, 60 feet underwater? You wouldn't think driftwood, right? You'd think, no way. We're talking trees still rooted in the ground, an entire ecosystem just sitting there at the bottom of the sea. How is that even a thing? Well, turns out it is. So check this out. Divers go down, and what do they see? These huge, bald cypress stumps standing exactly where they grew thousands of years ago. Their roots are still dug into the ancient mud. It's like a snapshot, a time capsule from the exact second the ocean just rolled in and swallowed the whole landscape. This wasn't just a pile of old logs. This was a library. So you find this incredible sunken archive. Now what? The big question is, how do you get it to talk? How do you make these ancient, silent trees tell you their story of, well, a complete catastrophe? Okay, so this is basically the detective work. Step 1. You look at the tree rings themselves, and they show the trees were growing just fine. And then boom, sudden extreme stress from saltwater. Game over. Step 2. You have to know when this happened. That's where radiocarbon dating comes in, pinpointing the exact moment the forest died. Then, step 3 is wild. They looked at pollen trapped in the mud around the trees, and it shows the whole environment just flipped like a switch from a freshwater swamp to the open ocean. And when you put all of that together, the age, the depth, the sudden death, you can actually calculate the speed. How fast did the water come up? And here it is, the big reveal. That little bar on the left, that's our old friend, the comfortable, slow 1 or 2 millimeters per year rise. And that giant bar on the right, that's what the trees recorded. We're talking up to 50 millimeters a year. That is not a creep. That is a flat-out deluge. It's more than 30 times faster than the speed limit we thought nature had. Insane. So you have to ask yourself, what in the world has the power to make the ocean rise that fast? The answer, it turns out, isn't local. It's thousands of miles away, locked up in the planet's massive, colossal ice sheets. Yes, scientists have a name for this, a meltwater pulse. And let me be clear, this isn't like an ice cube melting in your drink. This is like a dam bursting, a catastrophic failure of an entire ice sheet that just dumps an unbelievable amount of water into the oceans, all at once. We're talking about an event on a planetary scale. And for this poor forest in Alabama, it was like the perfect storm, a devastating 1-2 punch. So, punch 1. You've got this global event, this meltwater pulse raising the sea level everywhere. But then came punch 2. At the exact same time, the land itself was actually sinking. See, when those giant ice sheets to the north melted, the continent was like, phew, and the land underneath started to rebound up. But that pushed the edges, like the coast of Alabama, down. So you had rising water and sinking land. A total disaster.
Okay, so this is all fascinating ancient history, right? But here's what we bring it home. This is the so what part. What does this ancient flood, this drowned forest, actually mean for us today?
Because this is the key takeaway. That sunken forest isn't just a history lesson. It's a proven model. It's a direct, natural example of what happens. The very same forces at play back then, the sudden collapse of giant ice sheets, are exactly what has scientists looking nervously at Greenland and Antarctica right now. The past isn't just the past, it's a preview of what's possible.
And when you really let that sink in, the implications are just huge. For science, it's proof. It shows that yes, seas can rise terrifyingly fast when an ice sheet hits a tipping point. For all of us, for society, it means we have to completely rethink coastal planning. We can't just prepare for a slow creep anymore. We have to consider the possibility of sudden jumps. And for the people making the big decisions, the policymakers, this isn't a computer model anymore. This is hard historical evidence that says we need to act with incredible urgency to avoid pushing our own ice sheets over that same edge.
And man, this quote from the researchers just sums it all up perfectly. These stumps aren't just some weird thing to look at in a museum. They're a blaring alarm bell, a warning sent up from the deep past about just how fast and how violently our world can change.
So, when you boil it all down, it's pretty clear. That old, comfortable story of a slow, predictable ocean, it's been completely blown apart by this message from the deep. The warning has been delivered. The only question left is, are we going to listen?